We are bringing out brand new Sharpies for this one. Hey, let's calculate some stuff. This is the first of a series of videos we're going to be looking at the relationship between force, mass, and the rate of acceleration as it applies to final velocity or final distance. So we're going to be working through problems such as what force acts on an object with a mass of 10 kilograms if it begins 5 meters from a mark and has an initial velocity of 25 meters per second and ends up a final distance of 145 meters from the mark after an elapsed time of 4 seconds. So this is a pretty complicated problem, and what's more, this and the other problems we're going to do in this little short series of videos, this requires us to do two problems and then combine the results. And so the method that we've been using of what are we looking for and what do we have and how are they related, this method is absolutely necessary when we get to this stage. Back in the day, back when I was probably in high school or something, my father used to say this thing, and he used to say, it's time for you to put your big boy boots on and start walking. Time to put your big boy boots on and start walking. Now you can, I'm a gender thing. You can translate that, your big girl boots if you want to. It's time to start walking. This is going to be a little bit harder. What we're going to start with is what are we looking for and what's given. We're going to start with that scenario. And also, I'm going to divide my page. I'm going to divide my page into two sides because I got to do two problems. I'm going to have to do something to figure out the force, and I'm going to have to do something to figure out acceleration. So since I know this ahead of time, I'm going to divide my page into two parts. Broke out brand new Sharpies with a nice point. Maybe you'll actually be able to read. What is it that we're looking for? I'm going to start over here. I'm going to write what force. What force? Find F such that. Find F. Find F where? What else we got? So we know a relationship between force and mass and acceleration. The relationship is F equals ma. So I'm looking for m's and a's. Where? A equals and m equals. Well, right away at the beginning of the problem it says mass of 10 kilograms. So I'm going to put 10 kilograms in for my mass. Find A where, or rather find F where A equals something and A is not given. So we're going to have to get A from the other side of the page. We're going to have to get A from over here. So we're going to have to find A. So we're going to change over on this side. We're going to write find A where. Now, we've got some distances given, 5 meters and 145 meters, and we've got an initial velocity. If we're trying to find A and we've got distances, we're going to use the distance equation, which we learned in previous units. The final distance, d sub f, is equal to how far was it away to start with, d sub I, plus how fast is it moving to start with, multiply that by t, plus 1/2 A, that's what we're looking for, t squared. So I need a whole bunch of variables. I need some d sub f and d sub I and all that stuff. So let's go for d sub f, d sub I, v sub I, t. A is the thing we're looking for. A is what we're looking for. D sub f, the final distance is 145 meters. The initial distance is 5 meters. The initial velocity, looking for something like meters per second, 25 meters per second. Time, 4 seconds. A is what we're looking for. Once we find A, we're going to jam it into the equation over here, which that equation is F equals ma. We're looking for F, and we've got an m, so we're going to be looking for that A so we can jam it into this equation. Put your big boy boots on and start walking. That's what Dad said. Rewriting the equation, d sub f equals d sub I plus vi times t plus 1/2 a t squared. Some of you can say, like, well, you already wrote the equation. Why do you have to write it again? Because it's good math. 145 meters equals 5 meters. Because now I can just like go and find my variables and plug them in. Plus 25 meters per second times 4 seconds plus 1/2. I'm looking for A. And then T is 4. 4 squared. 145 meters equals, I can do 25 times 4 in my head. 5 equals 100. The seconds on the top, that's going to leave me meters. 5 plus, that's a plus. 5 meters plus 100 meters plus. 4 squared is 16. Half of 16 is 8, so that's going to leave 8A. Now the 8A is, we're going to eventually get that A, so we can combine terms. So I got 105 and I got 145. So I got 145 minus 5, that gives me 140. And then 140 minus 100, that gives me 40. So 145 minus 5 minus 100 is 40 equals 8A. So that's 40 meters, and that is 8 seconds squared A. 8 seconds squared A. 40 divided by 8 is 5 meters per second squared equals A. Getting the colored highlighters out. This is A. So I'm going to take that up here and I'm going to put it in for A. 5 meters per second squared. Now I'm ready to find F. F equals 10 kilograms times 5 meters per second squared. Kilogram meters per second squared, that's the units for newtons. 10 times 5 is 50. F equals 50 newtons. Look, we're using our method. What are we looking for? Find F where this is given, but we didn't have an A. So we go over here and we find A where this is given, plug in all the numbers, we calculate A, we jam it in there. Now, then we use those numbers to calculate the force in newtons. This is complicated. This is like taking our math to the next level. We're stepping it up. We're not just, putting numbers in a formula and solving. Now we're having to reason through what do we have given and what are we looking for. Taking that reasoning process, figure out the method. What are we going to, in the next videos, we're going to be looking for A or final velocity, or, we're going to be given no acceleration. We're going to have to calculate acceleration. So depending on what's given, you're going to have to do it one way or the other. But that is all for this video. Go back and rewatch it. The steps will be the same. If you have a find the force where and you have all this other stuff given, if you have a distance given, you're going to use the distance equation. If you have no distance given, maybe you have 2 velocities or a final velocity, then there's no final velocity in this equation. Over here, there's no final velocity. So if you have a final velocity, you got to use a different equation. Hopefully this was helpful. Please click the like button, subscribe to the channel, sign up for notifications. We'll see if we can flip the pin and catch it, because that's what we always do at the end. Caught it without looking. See you in the next one.